Hi everybody, this is Steve here. Today we're going through a very important but very classical LeetCode problem and also a very common interview problem which is called longest common prefix. But before we dive deep, please do me a favor and just smash that like button and don't forget to subscribe to our channel, which is dedicated to provide LeetCode tutorials to help fellow software engineers and CS majors to better prepare and ace through coding interviews. Alright, with that said, let's dive deep into today's LeetCode problem, longest common prefix. First, I think there is some confusion or ambiguity to clarify about this question. What is the longest common prefix? Some people might be confused what is the problem is asking about, especially like CS juniors or freshmen in computer science. What does this problem really mean? I see quite some confusion on Discuss board. See, for example, here, what does longest common prefix mean? Quite some people are confused. See, for example, this user was asking for the input ACA and CBA. Expected output is empty string. Shouldn't it be shouldn't be A rather than empty string? So this is pretty common confusion. So it's very worth to clarify it. So let's look at this question again. ACA and CBA, prefix. How do we define prefix? Prefix is the common letters starting from the very beginning, from index 0 of a string, right? So for this input, there are two strings in this array. So we start from the index 0 of the first string, which is A, and we'll check also at the first index of the second string, which is C. They don't share any common prefixes, right? In this case, of course, the correct answer is empty string. It's not going to be A. I think this user might be confused. He might be wondering, this question is asking us to return the common characters in this string, in the given list of strings, which in this case is not only A either, it's A and C, right? C appears in both strings as well. So this is some confusion and ambiguity that's worth to clarify. So the prefix, we need to understand the definition of prefix, which is starting from index 0 of every single string in this given list. Alright, with that clarified, we can start thinking about this problem. So basically there are two ways. We either do a horizontal scan. We basically scan every single word, right? Every single word given. For example, this is the test case example 1. We scan every word to check if the word has the prefix that we're checking for. That's one way. The other way is that we go vertically, right? We check the first index of every single word given in this string list, and the second index, every single character in the second position, and then we continue to check the third until we find there is a non-common character. Then we just return. These are the two ways. All right. I think we can get started coding with the first algorithm, which is we're going to do horizontal scan. So we'll scan every word to check whether this one has the common prefix. So we'll start from, we'll just assume the very first word in this given string is the longest common prefix. Then we'll just cut short every character by every character. Say, we'll just assume the flower, in this given test, flower is the longest common prefix. Of course, it might not be true. It could be true, which is a happy case, but most likely it's not going to be true in a lot of cases. So we're just going to start from the very first and the last index of this first word, and then we go all the way back here. So we cut this one off, cut this one off, cut this one off, cut this one off, until we find the longest common prefix, which is FL, by going through the rest of the list. Right? Make sense? I think we'll start coding, which we can go deep even further to help everybody on the same page to understand this code. So first, there are There are some corner cases. Of course, we're going to handle, say, if the input is now all strings length equals 0. In this case, we'll just return empty string as the problem defines. We'll just return an empty string here. Okay. Now we'll just say we'll call the result is, we'll just simply call it prefix. And as I said, we're just going to use the first string as the possible longest common prefix. And then we can start from the second word in this list, which is I equals 1, I smaller than strings length. Will remember this string's length, which is in this case is 4, right? This string's length means there are 4 words in this list. In this, if there are like another word in this list, the string's length is going to be 4. But we start from index 1, which is the second word, because we use the first word as the pivot, as the target that we assume this is going to be the prefix. It might not be true, so we will update this prefix along the way. It's going to be shorter and shorter until we find the one that can that does exist as a prefix for all of the words in this given list, right? Okay. Here, then we'll go through every single word, so here we start from the second word, and then we'll just cut through every single word that's in this possible prefix. Try to see when we can meet when we can meet the condition that this prefix is a prefix, this prefix candidate is a prefix of this current word that we are checking for. How can we do that? We can just check whether this given word, which is strings I, whether this given word has such an index. In Java, we can just call it index of prefix. So if we have this prefix, we can say if the index of, we're just finding a string of this word. If the index of, it could return 0. That means this is a prefix. See, if the prefix is fl, we take fl in this function, and strings could be flow, and then in this case, the index of is going to return 0, right? Which means this. So the method of this Java API is going to return the smallest value where this string, this prefix, exists in this string. That's the beauty of this API. So in our case, what we're going to do is that we're going to check until we find such a case, which means we're going to do a negation here, right? So until we find such a place where this index of string could return us 0, which means this prefix does start from the very beginning of this word, right? Then we're happy. Which means we're going to decrement, shorten the length of this prefix candidate one by one at a time, right? So it's going to be prefix. How do we shorten the length of a given string? We can just do prefix, we'll just cut it short, use substring method. Here, 0, and then prefix length. Every time we decrement it by 1. That's the way to get always. So we have the prefix, see the prefix length right now, it's we start from the very beginning. Prefix is 0, 1, 2, 3, 4, 5. So length is 6. Now 6 minus 1 is 5. In the next iteration, this prefix is not going to be flower anymore. It's becoming flower, right? This is what this line is doing. This line is shortening, is decrementing the length of this every single array here, every single word here. So the next time is going to be this, and the next time is going to be this, and next time it's going to be this after we do this operation, right? Until we get this one. So this one, after we pass FL, this string, as prefix candidate here, remember the prefix we start with the very first word in this given array. We use this one as the possible candidate for the longest common prefix. But we find that we begin from the second word, which is flow here, right? We find that we pass flower, this word flower, as the possible candidate for longest common prefix in here, and this string I is I equals to 1, which is flow. So we cannot get it to 0. The index is not 0. It's not the longest. It's not the prefix for flow. So we'll just decrement it by 1. Then next step, we get to this string, which is we cut flower by 1. We find that this flow is still not the correct one. So we'll just continue to cut it. We cut it to flow. And then we find flow is actually a prefix of the second word. So we will just stop here, right? Then we can just stop here. We'll continue to the next word. So right now, the longest common prefix, this prefix candidate, is flow, right? So, and right now we are at I equals to 1. So we finished this while loop because we find the prefix for the first two words, it is flow. This one here, right? Comment it out. Okay, there is a typo here. So in this case, we can just return prefix, right? We just find it. Of course, we can go through the last word, which is flight, right? So in this case, while just finished, we'll just increment I increments by 1, so we have I equals to 2, which is this word, flight. Now the prefix is this one, FLOW. We'll just say we pass this FLOW in here, and this word is flight. It's not going to be equal to 0, right? It doesn't equal to 0. So we just continue to decrement the shortened prefix string, which is in this case by 1. It's becoming FLO, right? So we check again. It's still not going to get us to 0, which means FL is not a prefix of flight. It's not, right? So we continue to execute this line, which means we decrement this common prefix, longest common prefix candidate. Now it becomes FL, right? Now we pass FL in here, and this one is flight. So we get to 0, which means we're going to break out of this while loop. And the outer side for loop, we continue to increment I by 1, so I becomes 3, which is not smaller than 3. So we're just going to exit. That's it. That's the entire algorithm. So this one is going to pass. But think about it. We have one more case, which could be like, say, for example, we have, what if we add another one here? Right, we add another A. Say we just add ABC here. We add another string here, ABC. In this case, while we finished iterating through the second word, we come here. When we're just going to decrement this entire prefix candidate all the way until where? All the way until an empty string, right? We're going to get to this position an empty string because when we pass FL to go through here, it's not a common prefix. We're not going to get 0. And we pass F in here, we cannot get anything out of this ABC. We'll continue to decrement until it becomes an empty string, right? So in this case, we can just trim this logic. Say if prefix becomes, okay, I'll call it prefix length becomes 0. What we'll do is we can just return 0. This is a small optimization because at this moment, no matter like say there could be 10,000 more words here, right? Still after ABC, in this moment there is no point to go through the rest of the array anymore, right? We can just simply return. It's going to cut us quite some time. time saving, right? That's basically the algorithm to go through this given list horizontally to check every single word one at a time until we find the shortest, the longest common prefix. Then we can just return. We can submit and see the result. Judging. All right, it's accepted and 100%. Fast. It takes 0 milliseconds. Of course, it takes some time. Well, that's the first solution to just scan horizontally. We just finished talking about the first solution, which is to scan every single array horizontally. Now we can talk about the second solution, which is to go through this entire string list vertically, which means we'll just check as I just mentioned, the first index of every single array, of every single word, the second index of every single word, the third index of every single word. That's what we call a vertical scan. So very straightforward as well. What we can do is first, we'll also check the corner case, which is whether this input is null or this one equals 0. In this case, we'll just return empty string. And then we'll have nested for loop. The previous one is a for loop, an outside and inside a while loop, which is similar. For here, we'll start from, so we'll use the first one as a beginning as well. So I smaller than, but in this case, we'll use the first one, the first word length, which means possibly we still assume this first word, the very first word, is going to be the longest common prefix. But of course, it could not be true, right? So we'll scan until the very final index, the very final character of this very first word. But still, we're going to cut it short, right? While we scan the rest, in the inside for loop, while we scan the rest of the words in this given array. Because like say this one, it's shorter than the first array. So there is no point to scan even further, right? Because there is one word after in this given array list. It doesn't even have like 6 or 7 characters here. So we'll just cut it short. So here we get this char out for simplicity. Strings will just char at. We'll get this. So remember, we use I to indicate. So this, we're talking about the second solution to this problem, which is we're doing vertical scan, like from top down, top down, top down, top down, until we scan to the shortest, the last index, the last character of the shortest word in this list, which in this case, in this example, it's going to be this W here, right? So we're going to use I to indicate this index for every single word. For every single character in every single word. So it's going to be 0 here, 1 here, 2 here, 3 here. This is what this I is standing for. So we get the 0 means the first word, which in this case is flower. We get flower, char at I is 0, right? I is 0. So I 0 means F in this case. It is F in this case, right? And then we have another for loop to go through every single other word, the rest of the word, starting from the second one, flow, right? So which means we'll use J to denote the word index. So J starts from 1 until the very last one, right? So J starts from 0, J smaller than string. This is string's length, which is the size of the list, right? So here, we use J. So J starts from 1, which is here again, until the very last. So J1 and J2. That's it, right? So here, what we can do. So first, what we're going to do is we have to check. In case like this, this current word that we're checking in the for loop is actually shorter than the very first word. In that case, we just need to cut it short. We can break out of this loop and return result already, right? How do we measure that? That's going to be J if I. So I is the index, the vertical scan index, right? So if I equals this, the current word that we are iterating through, oops, if it equals to this length, then we can just return, right? We're just going to return, which we're going to return what? We're going to return this, this j and substring, which is up to 0i. Yes, this is the longest common prefix that we can get. And another case is that, or if like we don't meet, like say this one, this I doesn't equal to O, I doesn't equal to O. In this case, which means this C is not equal to this char at I, right? What does this mean? This just means, say, we go through all of the characters in all of the words at index 1, they're all equal. So none of these two meet, the conditions meet, right? And all of the characters at index 1, they're all equal. So they're all fine. And then we have O. We are going through the third character, which is at index 2 of all of every single word in this list. So O equals to O character, and then we go through the third character, the third word in this list. So at this point, C is O. Then we check if O equals to J at this point is J is 2, right? 0. This is 0. This is 1. This is 2. This is the word index. So at this point, J equals to 2. So string J is flight. We check flight char at this moment, I equals to 2 as well. So we check, so char at I. So at this point, what do we get here? What we get is O doesn't equal to I, right? This is what we get for executing this line. So at this point, we know that this is not going to be, FLO is not going to be a longest common prefix, because the last word we cannot find FLO as the prefix, right? So at this point, we can just return this string J. You can string J, strings at J position, substring 0 to I. So this API is returning 0 is inclusive, I is exclusive. So it goes from 0 to, in this case, 0 to 1. So which means it's going to return FL. That's it, right? That's the entire algorithm. So after we go through everything, if there's we've never broken out from here, that means the very first word is actually the longest common prefix. So in that case, we can simply return string 0. That's a very happy case, but we need to go through every single word in the rest of the array list. Otherwise, we don't know whether the first word is the longest common prefix. But we definitely need to return it here. So that's the entire algorithm. We can hit submit and see. All right, it's accepted. So let's quickly recap this vertical scan solution again. So we'll just use index. We can use index here to denote the index, the character index of every single word in this given list. And then we start from the second word, which we use J to denote the word index in this given list. There are two conditions in the inner for loop. So first, we check whether the current index that we are going through in the first word, whether it exceeds the current word's length. If it does exceed, we'll just break out. Or if this current character that we're going through, it doesn't equal to the one that we extracted from the first word. That is this case. In either one of the two cases, we can just break out, right? And if we have finished iterating through the rest of the arrays and we still didn't break out, that means the very first word is the happy case, is the longest common prefix. So we're just going to return here. Well, that basically concludes the two algorithms, the two ways, the two solutions to solve this problem, longest common prefix. This is a very classical interview questions. It basically engages a candidate's understanding of the common string manipulation and the common for loop, while loop. How do you handle that? A very classical question. If you get asked during a real on-site or phone screens, good luck with that. I hope you can learn something from this tutorial. If you have any questions, please do leave me comments, feedback, questions, advice down in the comments section below. Again, please smash that like button and don't forget to subscribe to our channel. I'll see you guys in the next tutorial.